car is a wonderful invention when it's moving. But stick it in a traffic jam or on a conference room floor, and its usefulness is much reduced. The structure is still there, but the output, sadly lacking, lovely though this model clearly is. And the same is true for AI, one of the wonders of the modern world, rather hobbled without networks. Networks are the bedrock for intelligent connectivity and the profound transformation of our lifestyles and our businesses. So the acceleration of AI is in turn kickstarting a new wave of optical network growth, as noted by the global analysts Omdia in their latest report, 2025 Trends to Watch, Optical Networks. The report author, Ian Redpath, told me more.
It's really a generational phenomena. AI data centers, campuses used to be about $1 billion investments, and now we're hearing of $10 billion investments in these large purpose-built campuses for AI applications. So that in turn is driving a massive uptick in connectivity. We're in the 400 gig era today, and over the next year, we're going to rapidly move to a 800 gig era, and then to be followed on by terabit types of bandwidth in the future.
Well, you talk about gigabit and terabits, and in fact, petabits as well in terms of the per second capacity requirements, that ability of a data center to handle extremely fast and a great deal of data transmission. What else should we be looking out for?
Yeah, a couple of things. Network availability, network robustness, and reliability. So just fleshing those out a little bit, historically we'd have had a smaller number of links in between data centers, and to make it more robust, you want to get to a denser mesh situation, so many more connections per data center, and then you want that connectivity to stay up. So uptime is really crucial because you're supporting all these critical applications.
So what are the opportunities then for the network providers, the telcos, in meeting that demand for connectivity, both between data centers and between data centers and end users?
Yeah, for sure. So it really, if we start on the end user side, they've got to come into the network. So classically, carrier might have had a 10 gigabit connection. Now you're thinking about moving, massive data lakes into the AI trading centers. So they're going to need to step up at the edge. So, not the smallest enterprises, but larger enterprises, your corporate HQs where they have private data centers, they'll step up to 100 gig type of capacity on the access. We'll need an upgrade through the whole, what we're calling the AI middle mile. So if you've got a lot of 100 gig coming in at the edge, that network in the middle has to upgrade. And then you're looking at the core. So the DCI core, that's where we really start to see the petabit needs. And the carriers can come in and serve all of those different bandwidth requirements for their enterprise and for the cloud community.
So demand for AI applications is clearly only going to rise, and that in turn is going to demand sort of millisecond level latency or delay for a quality experience. How do the networks meet that demand and expectation?
Yeah, so there'll be a couple of different things that come into play there. So, taking optical right to the edge, and older networks had what we called OEO, where you would start at the electrical layer, go up into the optical layer, go back down into the electrical layer. All that up and down OEO adds latency. So you want to remove as much of that as you can. So have optical home runs right to the edge. And if you're doing a lot at the edge, it's got to be very economic. It's got to be cost effective. So getting optical to the edge and OTN to the edge to help that. And then, the core also will need an upgrade, and there it's all about cost per bit and, getting that higher performance, but at an economical price per bit.
So finally, no Mobile World Congress is complete without lots of very complex acronyms and abbreviations. The latest I've seen is MOFN, Managed Optical Fiber Networks. Tell us a bit more about those.
Yeah, we do love our quirky, kooky acronyms, and that's one that's come along. Really what it's about is building these large-scale networks fast. And so you've got a couple of different models. What the MOFN is a carrier will put together the fiber. The carrier owns the fiber, they have the network, and then they'll put together the optical equipment on top of it, and then they'll sell the whole thing to another entity that could be operating an AI business. And so these can be at different scales. So some of them are a little smaller, like more of an enterprise scale. So multiple enterprise sites maybe contain more than metro. And we've seen examples where these are very, very large. They cover entire countries. We even have pan-European examples covering Europe and fulfill high-capacity optical networks. So it's really, we're not talking about thousands and thousands of these, but they are happening and they're continuing to grow, and it's part of this whole AI ecosystem.
It's quite an exciting time, isn't it, for development and technology?
Yeah, we opened with the generational, and it truly is. You get these types of events that come along, once every so often that really catalyze the industry and catalyze a lot of growth and create a lot of excitement.